Exploring Mars has been one of humanity's most ambitious and fascinating missions, engaging generations of scientists, engineers, and explorers. Over the past decades, we've sent dozens of spacecraft, from the Viking landers of the 1970s to the rovers Spirit, Opportunity, Curiosity, and Perseverance, each delivering new surprises that have completely transformed our understanding of the Red Planet. For example, radar instruments aboard orbiters like Mars Reconnaissance Orbiter and Mars Express revealed hidden reservoirs of water ice buried just beneath the dusty surface, prompting the thrilling possibility that liquid water might still exist in subsurface aquifers today. On the ground, InSight's seismometer has recorded Marsquakes, showing that the planet remains geologically alive, while rovers have measured seasonal swings in methane that hint at active chemical or even biological processes. We've also witnessed colossal dust storms that can engulf the entire planet, as well as frost-driven jets of carbon dioxide ice sculpting the polar landscapes each spring. Far from a cold, lifeless orb, Mars is a dynamic world. Its shifting dunes, changing weather patterns, and subtle tremors teaching us vital lessons about how rocky planets form, evolve, and, perhaps someday, sustain life. Among the biggest advances in Martian exploration are the orbiters, satellites that circle the planet at various altitudes, capturing priceless images and data. One of the most important is NASA's Mars Reconnaissance Orbiter, or MRO. With its powerful camera, it gives us ultra-high-resolution photos of areas that land rovers could never reach. It was through this privileged viewpoint that science stumbled on one of the most enigmatic images ever taken of Mars. Dark streaks on dunes that at first glance look like rows of trees. Those images sparked many interpretations, often speculative. But to make sense of them, we need to understand how orbital observation works and the role these instruments play in scientific research. Mars exploration really is the result of a joint effort between cutting-edge technology and our relentless human curiosity. While rovers roam the surface, collecting samples and studying rocks, satellites keep a constant watch from hundreds of kilometers above. This panoramic view not only maps the terrain with precision, but also helps guide the rovers on their journeys. One of the most valuable satellites in this process is the Mars Reconnaissance Orbiter. It orbits Mars at about 300 kilometers above the surface and carries one of the most powerful cameras ever sent to another planet, HiRISE. This camera can capture details smaller than 30 centimeters across, everything from rocks and dunes to the rovers themselves, like Perseverance and Curiosity as they traverse the Martian soil. With such precision, HiRISE has become essential for studying climate, geology, and even the planet's structure. But the MRO isn't the only orbiter active around Mars. Since 2003, the European Space Agency's Mars Express mission has been probing for underground ice using radar that penetrates the Martian crust. Meanwhile, NASA's MAVEN mission focuses on the atmosphere, helping us understand how Mars lost most of its air over time. Together with the rovers on the ground, these orbiters make Mars the second best-studied planet in our solar system, right after Earth. Although each of these spacecraft has its own specialty, the MRO really stands out when it comes to image quality. Launched in 2005 and arriving in Mars orbit in 2006, it works like a multi-tool satellite. Besides studying the surface and climate, it serves as a communications relay between Earth and surface missions. Its scientific payload includes spectrometers, sensors, and radars that let scientists observe everything from underground layers to seasonal changes in the atmosphere. But its crowning achievement is still the HiRISE camera. HiRISE is an engineering masterpiece. It uses a 50-centimeter diameter mirror and sensors that capture images in 3 bands of the electromagnetic spectrum: red, blue-green, and near-infrared. This setup delivers jaw-dropping clarity. To put it in perspective, while many space cameras record meters per pixel, HiRISE works at 25 centimeters per pixel. It's like seeing a football field from space in incredible detail. Thanks to this technology, we can better understand the processes that shape Mars's surface. It was exactly this camera that, in January 2010, captured one of the most controversial images ever released of Mars. The photo showed what looked like dark rows of trees sprouting from dunes. To many, it seemed like proof of Martian vegetation. But the reality is even more interesting, and a great example of how natural processes can create captivating optical illusions. What you're actually seeing are dark streaks formed by material sliding down dune slopes. This happens because of a peculiar process involving dry ice, the frozen form of carbon dioxide. During the Martian winter, low temperatures let this dry ice build up beneath the surface. When spring arrives and temperatures climb, the solid CO2 doesn't melt like water. Instead, it sublimates, turning straight from solid to gas. That gas buildup causes little explosions that blast away the light dust on top, exposing the darker material underneath. These spots spread across the dunes, creating patterns that from afar strongly resemble branches, roots, or tiny forests. And this isn't the only phenomenon giving Mars's surface an exotic look. Dust devils, mini whirlwinds of dust, sweep across the plains often, leaving visible trails behind. Marsquakes also trigger landslides that alter the landscape, adding to or creating new markings. The interaction of wind, ice, dust, and ground instability makes for a highly dynamic environment. The landscapes are always shifting, even if slowly. As the ice under the dunes sublimates, the escaping gas carries dark sediments with it. The contrast between the bright surface dust and the darker layer below creates the striking visual effect that captured NASA's and the public's attention. These natural drawings, besides being beautiful, help scientists learn more about Martian soil. By analyzing the streaks and patterns, they can estimate terrain composition, sediment grain size, and dune stability. HiRise's ability to spot tiny details makes it perfect for capturing these events with precision. It offers us an almost artistic glimpse of the geological and climatic forces shaping the red planet. Images like these always spark public curiosity. Many online forums and social networks buzzed with theories claiming primitive plant life or alien activity. While those ideas are exciting, scientists have shown there's no evidence of life in these specific formations. They're simply the result of fascinating natural processes under Mars's extreme conditions. Still, it's hard not to be awed by the visual similarities between Mars and Earth. Even as a barren, lifeless world, Mars reminds us of some of our own planet's desert regions. That makes exploring it even more compelling. The thought that such a distant planet can look so familiar fires our imagination and makes us dream of the day humans will walk those red dunes. Though we know Mars doesn't host forests, rivers, or lakes like Earth, it's alive in its own way. With wind, dry ice, dust, and seismic activity sculpting unique landscapes, Mars reveals itself as a world in constant flux, full of secrets waiting to be uncovered.